We'll proceed in vector, summation, and integral calculus. Vector, summation, and integral calculus, the discussion that is unprecedented. It is not available in any of the book. People generally they tend to find a solution by dividing the problem into n different parts. This is a very big thing. If I have a problem, can I divide the problem into n different parts, solve part by part, and then assemble it? Okay, there are sometimes we feel that n is not enough. If I divide my problem into n different parts, then n is not enough. Then we make n tends to infinity. I have a problem, divide the problem into n different parts, solve part by part, and then sum it. Okay, once you sum it, once someone sum it, then he feels that n different part solution what we are providing, it is not accurate, it is approximation. In that fashion, we make n tends to infinity, means summation, that is sigma, and then summation of each item up to n time is not perfect. Then we make n tends to infinity. If we make n tends to infinity, then knowingly, unknowingly, it is only possible through the integral calculus, summation to integral. Calculating the single part solution, if I divide my problem into n different parts, computing a single part problem, computing a single part problem, we will do it through vector. This is the concept, we do it through vector. We are discussing about length vector. We have a discussion about length vector. Length vector is a vector that we have introduced, and this vector tackles the curve line also. If I have a line, if I have a straight line, I can represent a straight line. If I have a straight line, then I can represent the straight line through the vector. Any straight line can be represented through vector. How you can represent a straight line through a vector? Concept is very clear. Take any 2 points on the straight line and then make a vector. If a straight line is connecting 0, 0 to x, y, the vector is x minus 0, I plus y minus 0, j. If it is connecting 0, 0, 0 to x, y, j, a vector, then it is x minus 0, I, y minus 0, j, z minus 0, k. If it is connecting 2 point x1, y1, z1 to x2, y2, z2, then it is x2 minus x1i, y2 minus y1j, z2 minus z1k. This is the vector representation. But what about if it is connecting 2 points on a line, and line is not a straight line? Line is not a straight line. We have given an example like this. How I represent this straight line. I'm sorry, how I represent this curved line through vector, where one point is 0, 0 and another point is x, y. Here, this is x-axis, this is y-axis, this is origin, this is x, y. If I connect any point from 0, 0 to point x, y, that will go like this. Okay, then is it the representation of this line as vector? Certainly not. What is line representation of, what is a vector representation of line? Anyone would ask, what is the vector? What is the line first? Then we will think about representing the line through the vector. Line means a line. Line generally it is called a straight line, and that's why the straight line representation is vector. Okay, but if I talk about a straight line in this curved line, there are infinite straight line that is going here. It is made of a straight lines. Every point, how many points you will take from 0, 0 to x, y. If I take set of points, they will be infinity. If I take points on this line between 0, 0 to x, y, there will be infinity points. So many. At every point, line has a direction. At every point, line has a direction, every point, and that direction is a straight line. Straight line. Okay. No, no, no. Every point, if line is a curved line, then every point line is curved. Not true actually. Every point I can say the line is going in one direction. Yeah, that is true. Anyone would say yes, that is true. If I have a curved line, then I take any point on this curved line, I take any point in this curved line, at that moment, line is going in one direction. Or if I make a liquid flow through a curved line, there is a pipe like this, and liquid is flowing through this pipe. At any moment, what is the direction of the liquid? Anyone will ask, what do you mean by the direction? What I mean by the direction, consider this is origin. This is eastward. This is east. This is north. This is west. And this is south. Okay. Now person is going in I direction. Means he is going exactly eastward. Person is going in J direction. He is going exactly northward. Person is going in I plus J direction, or I plus J divided by a square root of 2. He is going in that direction. Person is going exactly 45 degree from the eastward. He has a direction. Okay. Person is going at 2I plus J, means 2I plus J divided by square root of 5 unit vector. That is his direction. Means the direction in which he is going, if I take with x axis as angle, then tan theta equal to 1 by 2. 2I plus j tan theta equal to 1 by 2. In that direction it is going. If I have a pipe like this, in pipe, liquid is flowing. Now tell me, hop. I really have a consider. I really have a pipe like this, and liquid is flowing in this pipe like this. At any moment, tell me the direction of the liquid. In which direction? At any moment, in which direction liquid is moving? Then someone would say, why don't you do one thing? At that point, calculate the tangent vector at that point. What is the tangent vector at that point? If you know the tangent vector, that is the direction of the liquid at that point. Tangent vector represents tangent line, or you take a tangent line at any point. Tangent line. If this is consider this is sinusoidal wave. This this is origin. This is sinusoidal wave. When it is at maximum here, what is the direction of the liquid? Maximum it is here. Okay, then it will be completely flat to the x-axis. Direction of the liquid is exactly eastward, I direction. Direction of the liquid will be exactly eastward. What do you mean? dy by dx will be 0 there. At that moment, y will not change when you move x. That is dy by dx. Change in y with x. What is change in y with x? If I take any point here, take a magnifying glass and then enlarge that point. If I take any point here, take a magnifying glass and enlarge that point and see the line. That will be a straight line. Okay. Now make if line is like this, then I take any point here, any point here, and then I enlarge that point. There will be a straight line going like this. If this is the straight line going like this, I have taken this much length of the line, that is straight. Then this is that is infinitesimally small, I have taken this x interception on x axis is delta x and y axis is delta y. Delta y by delta x will give the differentiation at that point, and it will give the slope at that point. Slope means if I talk about angle, then tan theta of that angle. Okay, if I take a sinusoidal wave, and this is the topmost point, this is sinusoidal. This is exactly sinusoidal wave. This left is origin. This is pi by 2 and top is 1. At this moment, if I take a point there and take a straight line at that point, it will be a flat line. Where if I take delta x, then delta y will be 0. Means delta y by delta x or dy by dx will be 0. So someone will say, then better if I have sin x, then I differentiate it. Whatever comes, I equate it to 0 and see at what point x derivative of sin x is 0. then at all those points the tangent will be flat. Yes, tangent will be flat. Okay, this is called direction of the line. Now, actually we are in discussion that how I can represent a curved line through the vector. We have talked about it many times. How I can represent a curved line through a vector. That is a big thing. Any line I can represent it through a vector. If this is a straight line and this is origin and this is x comma y, any point I can represent through vector connecting these two points xi plus yj. But if it is a curved line and this is x comma y and this is origin, if I connect these 2 points, it will be a line, straight line like this. It will be a straight line like this. If I connect any point x comma y with the origin, it will be a straight line like this. That line, this line does not represent the line. Line is every moment line direction is changing. We want tangent line, not this line. If it is a straight line, then luckily tangent and line are in same direction. If this is a straight line, every moment tangent line means any moment. If this point is x comma y, what is the equation of tangent line? Line means the line that is, if this is x comma y, at this point this line has what direction? That is it. That the direction is same as line, it's a straight line. But if it is a curved line, then every moment direction of the line is changing. Any moment, what is the direction of line? That is also called tangent line or tangent vector. What is the equation of tangent vector at any moment when I have x and y? Point is x comma y. This is also called length vector. Length vector, probably if someone search in the internet or book, he may not find. This is our fundamental called length vector. If you get a length vector means exact representation of a line through vector. So if I take a position vector x comma y, if this is x comma y and this is origin, then if I connect this point, this is typically called position vector. This is not the length vector. Length vector will talk about the direction of the line. This is not the direction of the line. If it is a straight line, then it will be direction of the line. But if it is a curved line, it will not be direction of the line. What will be direction of the line? If it is a straight line, then xi plus yj will represent the line. If it is not a straight line, then what is difference between? If I have a curved line, then every moment dy by dx is different. Dy by dx means any moment if I take a small section and delta x and delta y, the, the derivative of delta y by delta x at any moment is different. Here it is different, here it is different. Because delta y by delta x talks about the tangent line, and tangent line is different at different moments. With derivative at different moment will be different. If I take a straight line instead, then every point derivative will be same. dy by dx will be same every moment. But here it is different. So I have to represent a line, a curved line. If I want to represent a straight line through vector, I can take x comma y as a number also. Consider this point is 2 comma 3. This is x-axis, this is y-axis, this is y-axis, this is x-axis, this is origin. If this point is x comma y, this can be any number also, 2 comma 3. Then what is the vector? 2i plus 3j, 6. What is the vector from this point to this point? 2i plus 3j. 2i plus 3j talks about the magnitude also. 2i plus 3j divided by a square root of 13, that is the direction of this line, multiplied by whatever the magnitude you are taking. Simple. But if it is a curved line, then I cannot represent this line in numeric manner, because this line, if I say I have a exact representation of this curved line in a vector, then numeric vector is not possible. It has to be algebraic vector, where you keep changing value of x and y, and a vector will change its direction and magnitude. Changing vector. A vector that is changing. What is changing here? If I see every moment dy by dx is changing, or in a coarse term, if I say, if this is y and this is x, every moment y by x is different. Okay, but in an exact way, every moment dy by dx is different. Means this equation, the vector representation of this line must have variable component. If you skip variable component, then you cannot represent anything accurately. What is variable component in a curve line? Dy by dx is varying. Loosely, if I take y by x is varying, then y by x must be present in the equation of the vector that is representing this line. If I take any point here 0 comma 0 and this point is x comma y, then the straight line goes here. If it was a straight line, then xi plus yj would have represented this line, xi plus yj. Okay, but if it is not a straight line, then to represent curve line, I have to think about y by x, that is variable. Actual, I have to get dy by dx, but anyway, for time being, we will take out x from here, xi plus yj. It becomes I plus y by xj, bracket close into x. Now y by x, y by x at any moment, every moment y by x is different. If that is the case, then y by x, or in other way, we also say if I have a division where numerator is dependent upon denominator and denominator is a variable, then division must be transformed into differential calculus. So it will be I plus dy by dxj, bracket close into x. First term is function over x and y, or function over x. Because y is function over x, then dy by dx will become function over x itself. I plus dy by dxj. This is function, full is function over x into dx. This is called length vector. If I take out the independent variable and convert it into calculus, this will become a length vector. I plus dy by dxj, bracket close into dx. This is called length vector. What do you mean by length vector? Length vector means if you take any x, and y, if you replace in this, you will get the equation of the vector. Is it right? Yes. Anyone can try. This is called length vector. What do you mean? If you have a length vector, if you calculate the magnitude of the length vector, you will get the length of this curved line, because it is a length vector. I believe it is all right. Okay, so if this is the concept, then we will proceed again what example we are taking. Can someone think about more in the length vector? Okay. Okay, can we proceed more in the length vector? I think I have to take out this rubber. Okay, someone would ask me, can you talk about the length vector of a circle? Circle is also a curve, right? What is the vector representation of the circle? I plus dy by dx, y equal to square root of a square minus x square. I I plus minus x by square root of a square minus x square j, bracket close dx. This is the vector representation of the circle as per the length vector. What is the length? What is the length of the circumference? Just calculate the magnitude of it. You are joking. It's not possible. Yes, because it's a length vector. Length vector will keep changing. Length vector will keep length vector. Since it is a length vector, if you calculate the magnitude of it, then it will give you the length of the curve. This vector comes. Okay, what about length vector of a straight line? dy by dx you're talking, right? What is your straight line? My straight line is y equal to x. My straight line is y equal to x. Will it give the length of this line from 0, comma 0 to 2, comma 2? 2, comma 2 will fall on this line. 0, comma 0 to 2, comma 2, I have a line equation y equal to x. Then I plus dy by dx j, dy by dx is 1. So I plus j, bracket close into dx. Now you have to integrate it. X is from 0 to 2. X is 0 to 2. I plus j dx. Now you want magnitude. So you have to calculate magnitude of I plus j. So magnitude will come as 1 by a square root of 2. 1 by a square root of 2 dx. X is from 0 to 2. 1 by a square root of 2 into 2. Square root of 2. Okay, I think so. Okay, it is 0, 0 to 2. So this is 2 and this is 2. What is the distance? 2 square plus 2 square. 4 plus 4, 8. Square root of 8. 2 into a square root of 2. So it is not perfect the way I am saying. I'll try again. Okay, okay, I'm sorry, we made a mistake. So it is, we start again. I plus dy by dx j, bracket close dx. dy by dx is 1. I plus j dx, integration 0 to 2. Magnitude of I plus j is square root of 2, not 1 by a square root of 2. Square root of 2 dx, square root of 2, I can take out dx, 0 to 2, 2 square root of 2. Okay, what is the length of this circle? Okay, length of the circuit is I plus minus x by square root of a square minus x square j, bracket close dx. X is from minus a to a. If the circle has a radius of a, this is origin, minus a to a, minus a to a, and then in I plus minus x by square root of a square minus x square j, bracket close dx. Magnitude of this, what is magnitude? 1 square plus x square by a square minus x square. If you settle down square root, it will become a by a square root of a square minus x square. A by a square root of a square minus x square dx. X is minus a to a. This will give the top circumference. What it is? Someone take out a, and then 1 by a square root of a square minus x square dx will be sine inverse x by a, minus a to a. Sine inverse 1 minus sine inverse minus 1. Pi by 2 minus pi by 2. Pi into a. If I take both, 2 pi a. It is amazing. Length vector you take, it is amazing. There is something called parameterization. There is something called parameterization. So we will talk about. Let's start our discussion. Calculating the surface area of the circle through the vector summation integral. This is the discussion we have started. Calculating the surface area of the circle. Okay, if this is x-axis, then this is y-axis. This is Cartesian coordinate system. In the Cartesian coordinate system, we are taking polar coordinate system. If this is radius, radius is moving like this and it is making 360 degree. Okay, in that fashion, we can cut this angle. If radius is making like this, radius is making like this 360 degree. I cut this 360 degree into n part. Then this is the first part, this is second part, this is third part. Like that we have n part. This is the ith part. Consider this is the ith part. This is the ith part. This is the ith part. What is the area of the ith part? Area of the ith part is this vector cross product with this vector. This is another way also we can take. This length vector cross product with, I'm sorry, I'm really sorry. This length vector and cross product of the arc vector. Okay, what is area? So this is going like this. So this is radius. This is radius vector. This is radius vector. And this is also called arc vector. The curve vector. If I take this curve vector, this is a curve, right? This is circumference is a curve. If I represent the circumference in a curve vector, length vector, and if I know the length vector of this, if I do the cross product of it, it should give the area in between as per the fundamental of vector. So ith section, what is the net area? Summation I equal to 1 to n. Area of the ith section. Area of the ith section is curve vector cross product with the radius vector. Make sense? Radius vector is r vector. Straightforward. If this is radius, then this is r vector if I take in polar coordinate system. What about this curve vector? What about this curve vector? Any vector in polar coordinate system. What is this point in polar coordinate system? Consider this is at distance r, then r, comma, this is at angle theta. This is at angle theta. Then this point is r, comma, r theta. R theta is the arc. Both should be, I cannot say r comma theta because this is Cartesian coordinate system. Every point must be in a displacement. If I say r comma theta, r is angle and theta, I'm sorry, r is distance and angle is theta. Both has to be displacement. So it will be r comma r theta. R comma r theta. Okay, so what is the vector representation of if I say what is vector representation of any vector in Cartesian coordinate system xi plus yj? This is a generic way. Similarly, in Cartesian coordinate system, if I talk about the vector representation of the polar coordinate, then it is r comma r theta, r unit vector plus r theta unit vector. Make sense? If I talk about the length vector, then among r and theta, which is variable here? If I talk about the arc, then theta is variable. So I'll take out theta from here. Then it will become r by r unit, I'm sorry, r by theta, r unit vector plus r theta by theta, unit vector, bracket close, into theta. If I push into differential calculus, now if I say that if I say about this arc, then radius is not changing. If I talk about this arc where it is moving delta theta, I am talking about the ith section. I have divided this angle full 360 degree into n part. This is the ith part. With x-axis, it is making angle theta. Then this angle is delta theta I. This angle is delta theta I. In that fashion, this arc is an arc that touching this point and this point, where radius is not changing, only angle is changing. So if I take the length vector of this arc, it is r by theta, r unit vector, plus r theta by theta, unit vector, bracket goes into theta. R by theta or dr by d theta will be 0 because radius is not changing. And that side it is r theta unit vector. It will remain as r theta unit vector. R theta unit vector, r theta, so it will come as, okay, it will come as r theta unit vector, d theta. This is the very funny length vector of this arc. What is length vector of this? If I take in fashion of r unit vector, r theta unit vector, then I have to take out r because radius is changing, not the theta is changing. In that fashion, we have r. If I take out, it becomes r by r unit vector plus r theta by, in r theta r is constant, r theta by r theta by r theta unit vector, bracket close, outside is r. Here theta is not changing, that component will become 0. R by r1, r unit vector, dr. Cross product of these two will give the area underneath it. R unit vector cross r d theta unit vector. Cross of these two, that will come as r dr d theta if I take the magnitude. R dr d theta. R dr d theta. Okay. Now d theta and dr I can represent as d theta is this. D theta is this. Then what is dr? Then this is r vector. Now, hope. So I'll rephrase it. What has come as the area of the ith section? Hope. What has come as area of the ith section? The area of the ith section has come as r d theta dr. R d theta dr. Okay, r d theta dr. If I talk about r d theta dr, d theta is delta theta I because we varied in the theta. What is dr? Dr means if I want to calculate area, I have to cut radius into m part. I cut theta into n part. That is true. I cut theta into into I cut theta into n part. If I talk about area by cutting it into n part, then I have to cut radius also. Because when we calculate area, there are two things that comes into the picture. So radius also I have to chop into m part. If this is delta theta I, then this is delta r. Somewhere I'll take jth section, first section, second section, jth section. This is ith section in theta, then this is jth section in radius. Okay, more or less we are talking about this section where we have this section as delta r and this section as delta theta. Whatever. Now ith section area will come as r delta theta I delta r j. Now a summation will come at delta summation I equal to 1 to n, j equal to 1 to m if I chop the radius into m part. R delta theta I delta rj. Okay, then it will come as whatever we want. Is it the perfect solution? Is it the perfect solution? What do you mean by perfect solution? What I mean is, what about if radius is changing with the changing of angle? R equal to cos theta, that is the next equation. What is your circle equation? My circle equation is r equal to cos theta or r equal to sin theta. That also makes a circle. If someone draws r equal to cos theta, it makes a circle. Many times we have described it. R equal to cos theta. If this is origin, this is x-axis, this is y-axis. If this is origin, r equal to cos theta when angle is 0, radius is 1. When angle is 90 degree, radius is 0. When angle is more than 90 degrees, the radius starts growing, but it is negative. So this side will be positive. And when angle is 180 degree, radius will be full. It will make a circle. R equal to cos theta. What do you mean? If I take ith section, if I chop the angle into n different parts, then this is the ith section where radius is changing with the angle. Radius is changing with the angle. If this is radius at one point when it is at angle theta, then this is it has moved delta theta I. This angle with x-axis is theta per delta theta I. In that fashion, radius is changing. Use now use your use your length vector to compute the area. This is a challenge to you. This is a one vector you talked about. This is a curve. This is a curve. This vector cross product with this vector, I say this is the area. Now you tell me how you would proceed. Okay, if I take this vector, then certainly theta is not changing. If I take this vector, then theta is not changing. Angle is same. But if I take this vector, then theta is changing and radius is also changing. What is this vector? This vector is r unit vector plus r theta theta unit vector. I have to take out r. It becomes dr by dr r unit vector plus r d theta by dr theta unit vector bracket close dr. D theta by dr is 0 because theta is not changing with the r. It is dr by dr is 1. It is more or less r unit vector dr. This is the vector dr r unit vector. What about this vector? What about this vector? Okay, if I take this vector, then it is r unit vector plus r theta unit vector. Okay, I have to take out theta because theta is variable. The someone will say radius is also variable. Which one we will take out? Let's take out theta. If you take out theta, all right, then it will become dr by d theta r unit vector plus r plus d of r theta because both are variable. D of r theta by d theta unit vector bracket close d theta cross product of these two, that will be dr r unit vector cross product with dr by d theta r unit vector plus d of r theta by d theta unit vector. Someone can come bracket close into d theta. It is too complex. No one can calculate the area of this variable radius. If radius is variable with theta, no one can calculate with the concept of the with the cross product of two length vectors. Then is it your length vector is not accurate? It is accurate. This is called parameterization. There is a new technology that is called parameterization. Parameterization means we denote our xy through another parameter. Okay, what is parameterization? Consider I have a curve line that is called curve line. That equation of curve line is y equal to square root of a square minus x square. Square root of a square minus x square. Let's say x equal to a cos theta and y equal to a sine theta. Then how it will become? Then it will become like it will become okay. What is okay? Y equal to a square root of a square minus x square. If I say x equal to a cos theta and y equal to a sine theta, okay, if that is the case, then what is the position vector? Position vector of the circle. If I talk about the circle, calculus is very minute. With little mistake, anyone will make a big mistake. So this is a circle. If this is a circle, then what is the position vector? Consider this point is x comma y and this is origin. If I draw a straight line, that is xi plus yj. Now x equal to r cos theta, a cos theta, y equal to a sine theta, where a is constant. In that fashion, it becomes a. You have to keep outside cos theta I plus sine theta j. Okay, can someone see something here? Everything in Cartesian coordinate, it is tuned by theta. I can say it is a function, this vector rotation, that is a, and then cos theta I plus sine theta j, it is a function over theta. I have a new vector, and that vector is a function over theta. Just tune the theta, and you get new set of x and y. No need to go for x and y. Only theta is theta. If you make theta as variable, then theta will control new set of x and y. This is called parameterization. You are parameterizing the Cartesian coordinate system as far as circle is concerned. So circle, if you have xi plus yj or xi plus square root of a square minus x square j, that can be parameterized by single component as theta, and that theta is cos theta I plus sine theta j. This is called parameterization, means giving the handle of your coordinate system to another coordinate system. This is called parameterization. If you have if you have set of variable, rather than mucking with the variable full, you have a one third variable. Okay, that variable will tackle all. I believe in design pattern, this will be facet design pattern. Facet is a design pattern that is comes under a structural design pattern, where if someone has lot of complexity in the software, then he want to ask the client to call to call the function so that he can use the software. There are very high complexity is there, then he will go with the another API called facet. Facet API will have very few parameters. If it tweaks with the facet will go and change all these complex parameters. To the client it should be easy. Okay, this explanation comes in parameterization, where x y coordinate system we manage through different coordinate system, and that is called polar coordinate system. Means if I have x y coordinate system, x y coordinate system, x y coordinate x y coordinate system, then I will have another coordinate system called r theta coordinate system. And through r theta coordinate system, we will manage this x and y or this circle, and everything will be controlled. So we have now brought in something called controller. Controller will tweak the x and y. We will not tweak the x and y directly. Then we will compute the area. Okay, watch our previous four videos. We have talked about how to control r and theta. How to control r and theta in theta r plane to have the area of the circle. So to find the area of the circle through length vector, if I'm trying to find area of the circle through length vector, then this length vector, that is the arc vector, and this length vector, that is the radius vector, they will be controlled through theta r plane, not directly here. We are messing up directly here. It will be controlled through second coordinate system called theta r plane. Okay, I believe I will proceed on this. So through theta r plane, how I can proceed in calculating the area of the circle? where I have this length vector and this length vector. If I do cross product, then I'll get the area of the ith section if I chop the angle into n part. Okay, if I get, or I can describe here only, if I have theta or plane, okay, if I have theta or plane, then I have r equal to cos theta. If it is r equal to cos theta, then this is the waveform it is making in theta or plane. If this is theta, then this is r. R equal to cos theta. R equal to cos theta. This is the graph it will make. Where when theta is 0, it is 1. When theta is 90 degree, it is 0. Like this. This is the graph it will make, that is cos. R equal to cos theta. If r equal to cos theta, or let's say r equal to sin theta, r equal to sin theta also makes a circle. That circle will be like this. If someone is saying r equal to sin theta, then it will form a circle like this, where this is origin, this is x-axis, this is y-axis. This is the equation of r equal to sin theta. I did it so that it will be easy to draw in the r theta plane. This is r theta plane. This is r equal to sin theta. Okay, how to calculate the area of the ith section we are talking, where radius is variable, radius is changing. In that fashion, if I take r theta plane and this is a sine r equal to sine theta, then chop to what angle you want. If I take r equal to sine theta, it forms a full circle when theta moves 0 to pi only. Anyone can draw. R equal to sine theta, it makes a full circle. If theta is going 0 to pi, not 2 pi is required. If someone makes 2 pi, it will make circle twice. Only variation of theta with 0 to pi, it makes a full circle. If I take r equal to sine theta in theta or plane, let's chop, oh, this is the r equal to sine theta. Let's chop 0 to pi into n part, and let's chop 0 to a into m part. M for Montana in US. So this is 0 to a, and let's chop into m part. 0 to 2 pi, let's chop into n part. A is the maximum, or here a is 1, maximum is 1. So 0 to 1, this let's chop into m part, and 0 to pi chop into n part. Let's take one rectangular region here. Take one rectangular region here. The left bottom corner of rectangular region is theta comma r. Then area of this rectangular region is, if I have taken ith section along the theta and jth section along the r, then there we have a rectangular region. In rectangular region, we have a flat, this side. This side, if I take where theta is varying, r is constant. If I take this side, then r is varying, theta is constant. Bottom left corner is theta comma r. If it is theta comma r, then this is theta plus delta theta I. This is theta comma r plus delta rj. This is the rectangle. What is the mapping rectangle? Mapping rectangle in xy coordinate system. If this is the, we are talking here, where radius is changing. Even though radius is changing, the mapping rectangle from there to here, we have two sides. One side is radius is changing, theta is constant. Other side is theta is changing, radius is constant. So we have to take this arc as theta is changing, radius is constant, even though I am seeing radius is changing, because it is getting guided through the another coordinate system, where we have taken a rectangular region inside a sinusoidal wave, where theta is changing, radius is constant, radius is changing, theta is constant. Accordingly, I have a this section in the Cartesian coordinate system. The mapping of sinusoidal wave mapping of sinusoidal wave in r theta plane is, this one is xy plane, where origin of the circle is at the bottom. Origin of the circle is at the bottom. This is x axis, this is y axis. This, if this is the radius, this is 1. If this is the radius, when angle is 0, radius is 0. The way angle is growing, radius is growing. When angle is 90 degree, radius is full. When angle is growing, radius is decreasing. When angle is 180 degree, radius is 0 back. This is the circle. If I cut this angle from 0 to pi into n part, then this is the ith section. If this is the ith section, then we have this is delta theta. This is delta theta. If this is delta theta, I can take in along the radius, I can take delta r. This is the section. If this is the section, then if I talk about this where theta is varying, I have to keep r constant, must, as per the boss is guiding from that side. This is called parameterization. Parameterization means I have dedicated my complexity of problem that is in xy plane to theta r plane. And this is delta r, this is delta theta. One side r is constant, one side theta is constant. If that is the case, then it will come to r d theta dr again, the way we started the discussion. R d theta dr. Now integration r d theta dr. Or if I talk about the ith jth section, it will be r delta rj delta theta I. Summation I equal to 1 to n, summation j equal to 1 to m. Okay, please watch our previous video. This I can represent and function summation I equal to 1 to n, summation j equal to 1 to m, function over theta r, delta theta I, delta rj. This is a fit case, function over theta r, delta theta I, delta rj. It is a fit case to convert into integral calculus. It will be r d theta dr. Limit theta is 0 to pi. What about r? Okay, if I take the sinusoidal wave in theta r plane, we are now integrating over the sinusoidal. If we are integrating over the sinusoidal, this region, integration of the theta and r, how theta and r are varying in theta r plane. Okay, or integrating over a region in theta r plane. Okay, if I go beyond it, then if I am calculating integration sine theta r from begin to end, function over theta r, d theta dr or d theta r, it is calculation of a volume. If I say x and y begin to end, function over xy, dx dy, it is a calculation of a volume. Calculation of volume means I have a theta r plane. This is theta, this is r, theta r plane, and height is function over theta. Okay, if I calculate function over theta r, that is the height, d theta dr, and integrating over one region. If I have a 3D shape, then 3D shape has x, theta and r in theta r plane. It has theta and r in theta r plane. Theta and r is confined in the sinusoidal curve only. I have to take theta r within this one, not beyond it. So I have to integrate this volume, whatever volume we are calculating, I have to integrate this volume in a region on theta r plane where all the point will come inside the sin x only. If this is the region we are integrating, then theta will go 0 to pi and radius will be variable, because we have to make radius as a curve line, means radius everywhere, radius is changing. So integration will come as, so we have to integrate to calculate the volume function over theta r dr d theta. On the theta r plane, it will be a sinusoidal region against which we have to do the integration. Because I cannot take any point away from the sin x line. Those theta r is not variable. Theta r must be in the sin x. Sin r equal to sin theta curve. In that fashion, radius will go as a sin theta and theta will go 0 to pi. 0 to pi theta and radius 0 to sin theta r d theta dr. This will give the area. So whenever we go for parameterization, make sure that control should come from the parametric world, not directly on the xy plane. If I start thinking on the xy plane, then we will mess up so many things. This is a big lesson. We will move in the parameterization. Parameterization in vector to do the complex computation. Okay, we will see more on it. Please do not mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610 is the telephone number.